Good afternoon, everyone. It's a lovely, sunny California Friday afternoon here where I am. This is Henry from ASM Tutoring, once again attempting to serve as your wise old sensei. Today we'll finish off the example about calculating center of mass for a continuously distributed mass. So let's head over to the whiteboard. If you'll recall from last time, we got to this point, and now we just have to plug in numbers to find the actual center of mass where the limits of integration are from 0 to 4. So because there's, in this first one for the mass, because there's a negative coefficient here, we can reverse it and make it positive. So we can make this pi over 2 e to the negative 2x from 4 to 0. Again, we've reversed the limits of our integration because we changed the negative sign to a positive. So if we plug this all in, we have pi over 2 times e to the 0 minus e to the negative 8. Well, anything to the 0 power is always 1. So this equals pi over 2 times 1 minus 1 over e to the 8. Because with a negative exponent, you take the reciprocal and make the exponent positive. So that's our mass. Now let's find the integral of x dm. We found the expression using integration by parts, and now we'll plug in actual values. So again, the negative here and the negative here, we can change those to positives by reversing the order of limits of integration. So we can change this to pi times x 1/2 e to the negative 2x plus 1/4 e to the negative 2x with the limits from 4 to 0. We're effectively going backwards because we flipped the sign. So now let's plug that in. So this gives us pi times 0 plus 1/4 e to the 0 minus 4 times 1/2 e to the negative 8 minus 1/4 e to the negative 8. Okay. So e to the 0 is just 1. 0 drops out, of course. So we have pi times 1/4 minus 2 over e to the 8 minus 1 over 4 e to the 8. So we put that entire expression over the mass expression, which was up here. Pi times 1 minus 1 over e to the 8. Pi over 2, I'm sorry. So here's pi over 2 over 1 times 1 minus 1 over e to the 8. Okay. So pi's drop out. The factor of 1/2 in the denominator, effectively that's multiplying the numerator by 2. So if we do that, we get 1/2 minus 4 over e to the 8 minus 1 over 2 e to the 8 all divided by 1 minus 1 over e to the 8. Well, that's a lot of fractions and denominators. Let's make life a little bit easier by multiplying everything by 2 e to the 8 over 2 e to the 8. And if we do that, we get e to the 8 minus 8 minus 1, right? Yeah. All divided by 2 e to the 8 minus 2. We can combine the minus 8 and the minus 1, and that gives us e to the 9 minus 9, all divided by 2 e to the 8 minus 2. Okay, so that would be the x-coordinate of the center of mass. Let's plug in the actual numbers here. Pull up our calculator. Sorry, this should be e to the 8 on top. I don't know why I put 9 there. It should be e to the 8 on top, minus 9. Okay. Now, e to the 8 is very large, especially compared to negative 9 and negative 2. So this roughly should equal 1/2. Let's see if our calculator agrees. So punch in e to the 8. E to the power of 8 equals. So let's put that in the memory. Okay. And we'll subtract 9. And we'll divide all that by the quantity 2 times the memory recall minus 2 hold on, calculator's not cooperating here. So e to the power of 8 equals, so let's just write this down, 2980.958 roughly, minus 9 over 2 times 2980.958 minus 2. And let's punch that all in your calculator. So minus 9 equals 2971.958 divided by 2 times 2980.958 minus 2. And that's 5959.916. And if we work out that quotient on our calculator, 2971.958 divided by 5959.916 equals 0. What was that? 499 roughly, which almost equals 1/2 as we previously guessed, because e to the 8 is so large compared to the other numbers in this quantity. So now we take that That was our integral of x dm. Oh no, that was the whole thing, right? We've already divided by the mass. So the x-coordinate of the center of mass would be roughly at about 0.5 or 1/2. That would be the x-coordinate of the center of mass of this hypothetical distributed solid mass. This concludes today's lesson. This has been a discussion or completing the discussion of an example of how to find the center of mass of a continuously distributed mass. I know that was rather long-winded, but we did want an exact solution. If you'd like to learn more, I'm available for hire as a private tutor. You can see my contact information in red at the top center of this whiteboard. The first 1-hour lesson is free for all new students. Try before you buy. You take no risk. The burden of proof is entirely on me to demonstrate outstanding service. And as a thank you for watching all the way to the end of today's lesson, please mention the code FREEBOOK when you contact me. And at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. This book is also available for purchase on the Barnes & Noble website. I wrote this book in an effort to provide guidance and advice to help students, particularly high school students and college students, to succeed in school, in work, and in life. Thanks for watching. Have a good day.